This is exercise 5.3, which introduces another new rule, this one the conditional introduction rule. All right. So with 5.3, we've got three of the operators, and we've got introduction elimination rules for each. All right. Now the conditional introduction rule is a little funny. All right. And you can kind of see that just looking at how it's written. All right. All right, the basic idea though is you want to prove that a conditional is true, or you want to derive a conditional. If P, then Q. How do you do that? The easy short answer, you assume P and you derive Q. If you assume P and derive Q, you've proven that if P is true, then Q is true. All right? So that's the idea, that if this conditional says if P, then Q. I can prove that by assuming P and deriving Q. So why does it look like this? Well, this is an assumption, P. It's not something you've proven. It's not something you know is true. It's something you're assuming to try to derive Q. So what happens is it gets indented. So notice how these two lines are indented from this line. So we indent it because we're assuming it. We don't know it's true. And so we have to set it off or indent it from the rest of the derivation. Because I always compare it to when somebody's sick. You quarantine them, right? Because you don't want the sickness to spread. Well, this is kind of like being sick in the sense it's not proven to be true. And so since it's not proven to be true, we quarantine it from the rest of the derivation, which is proven to be true. Okay? So we assume P, and we write this here want Q just to remind ourselves what we're trying to get. This part here has nothing to do, like it's not a premise, it's not something you can use. It's just like a note to yourself. I'm assuming P because I want to get Q, and that'll prove that if P is true, then Q is true. Okay, so want Q is like note to self, this is what I need to get. And when you finally derive Q, then you've proven the conditional is true. That's why the conditional goes back on the original line, because this is proven. If you assume P and you derive Q, you have proven that if P is true, then Q follows. All right. So let's see how that looks in actual derivations. Now, see how this is one step. There could be lots of steps in between. All right. So let's take a look at number one just to see what it looks like. Now, when do you use conditional introduction? Well, when you're trying to derive a conditional. Okay. So you can see here our conclusion is if C, then W. So what do? We indent, we assume C, and we want W. So notice the assumption is always going to be the antecedent of the conditional that you're trying to derive. And what you want to finish this is the consequent of the conditional. And you have to remember to indent. You can, if you want, put that vertical line there too, just to remind yourself. All right. So this is not, C is not something we proved. It's just something we're assuming. So that's why it has to be set off. These premises up here we know are true. These are given to us as true, so they go over on this line here. This is called a scope line. All right. But C we don't know is true. It's an assumption, so it goes here. Now we can use C now like a premise, right? It's assumed, but now we're going to use it just like we would any other premise, although we're going to keep indenting. So now we have a conditional over here, if C then G, and we have the antecedent of that conditional. So if you remember the conditional elimination rule, if we have a conditional and the antecedent, we can derive the consequent. So we can get G by conditional elimination of 2 and 3. Right? 2 is a conditional, 3 is the antecedent, and we can get, therefore, the consequent. Okay? So now notice once we make this assumption, we use it just like a normal premise, right? Although it's always going to be indented because the assumption, again, we don't know if that's true or not. Okay, so we indent. Now we can use G to get W by the same reasoning, conditional elimination, this time 1 and 4. So line 1 is a conditional, line 4 is the antecedent of that conditional, so we can thereby derive the consequent W. So now, that's what we wanted, right? If you remember, we made this little note to ourselves up here that we want W. So, since we got W, that part is done. We can come back to the original line, and we can write if C, then W. That's our conclusion. Now we justify this by conditional introduction. And how did we introduce a conditional? Everything that was indented was used. So we write 3 hyphen or dash 5. It's not comma because it's not just line 3 and line 5 alone. It's everything in here, right? This whole thing is what we used to prove that if C, then W. So it's the whole thing. So 3 through 5, right? Not just 3 comma 5. All right. And this part here is called a subderivation. Subderivation because it's like a little derivation inside the main one. And again, we wanted to prove if C then W. We did that by assuming C and deriving W. So therefore if C then W. So this subderivation proves this conditional. Now nothing in here was proven, right? But this is now proven, if C then W. Okay, let's go to number 3. Again, our conclusion here is a conditional. So let's indent. Let's assume the antecedent of the conditional. I'll put the line there just so we keep straight. And we want E. In other words, we want to get E to end the subderivation. Alright, but now we can use C just like we would a premise. And that's one of the advantages of using the conditional introduction rule. It gives you an extra premise to work with. Now again, it's not a proven premise. It has to stay indented over here. But you can still use it like you would use any other premise. So for example, now we can get A and C by conjunction introduction of 2 and 3. 2 is A, 3 is C, so we can put them together into a conjunction. Why did we want to do that? Because that's the antecedent of this conditional. So now we can do conditional elimination. 1, 4. 1 is a conditional, 4 is the antecedent. And again, remember you have to have the whole antecedent to apply conditional elimination. You have to have A and C. You can't just have A by itself, you can't just have C by itself. You have to have the conjunction. Everything that comes before the horseshoe. You have to have all of that before you can apply this rule. Okay, but again, now E is what we wanted, right? We made this note to ourselves. We want E. Now we've got E. So we can go back to our original scope line, write C then E. Conditional introduction. Our assumption happened on line 3. We got our consequent on line 5. So we write conditional introduction 3 through 5, because again it was this whole subderivation that proved if C then E. So the first number is where your assumptions start, where you started the subderivation with an assumption. The last number is where you ended the subderivation by getting whatever it is you wanted. And again, it was the whole thing, so you write 3 through 5, not just 3 comma 5. Okay, number 5. Again, our conclusion is a conditional, so we'll start by indenting and assuming the antecedent of the conditional we're trying to derive, J, and we want L, the consequent of the conditional we're trying to derive. So again, this is just a note to yourself to remind yourself what you're getting. It's not a premise you can use or anything like that. Okay, so we need now to get L, we need J or K, because remember, to do conditional elimination, we need the whole antecedent. So how do we get J or K? Well, remember our disjunction introduction rule says if I have any sentence P, I can put it into a disjunction with any other sentence. So I have J, so I can put that into a disjunction with any other sentence, including K. So again, why did I do that? Because I wanted that antecedent of that conditional. Now that I have it, I can get L by conditional elimination 1, 3. So line 1 is the conditional. That's right, I write 1 here. Line 3 is the antecedent of that conditional. So I write 3. This is the rule I applied. These are the premises I applied it to. And my output, or the thing I get, is the consequent. And again, that's what I wanted. So my subderivation is done. And I've proven J conditional L by conditional introduction 2 through 4. 2 was my assumption, 4 was where I got the consequent. So this whole subderivation proves that if J, then L. Okay, number 7. Again, our conclusion is a conditional. So indent, assume the antecedent of the conditional you're trying to derive, want the consequent. GNH, the whole thing. Now we just proceed as we would in a normal derivation, though we always remember to keep indenting. So now we have a conditional and the antecedent, so we can get the consequent by conditional elimination of 1 and 2. Line 1 is a conditional, line 2 is the antecedent, so 1, 2, and that gives us as a result the consequent. But still, that's not what we want, right? We have to still do more work. We have to namely put G and H together into a conjunction. So that's conjunction introduction of 2 and 3. Right, line 2 is G, line 3 is H, so the conjunction introduction rule says I can put those together and do a conjunction. And that's what I wanted, right? Want G and H, so I'm done. So I can write here if G, then G, and H. And that's by 2 is my assumption, so it's conditional introduction. 2 dash line 4 was where I got the consequent. So conditional introduction 2 through 4. Alright, last one. Here we have conditional as our conclusion. So we indent. We assume our antecedent. And we want the consequent. So assume not D. So this will prove that if not D is true, then not F is true. Alright, so now again we keep indenting until we get what we want. So with not D we can do a disjunction elimination of 1 and 3. So line 1 is a disjunction, line 3 is the negation of that one of that disjunct. Sorry, that should be not E. So that gives us as a result the other disjunct, which is not E. Again, keep indenting until we get what we want, and we can do that right now. We can get not F by the same reasoning. Here we have a disjunction, here we have the negation of one of the disjuncts, so we can get the other disjunct. So it's 2, 4. Line 2 is our disjunction, line 4 is the negation of the E. So not F is what we wanted, so we're done with the subderivation. So we write not D, conditional, not F. That's by conditional introduction 3 through 5. So again, the important things here for conditional introduction, always indent the subderivation. Start with the assumption of your antecedent that you're trying, of the conditional you're trying to derive, so that's not D. End the subderivation with the consequent of the conditional you're trying to derive. That proves that if D is true, then not F is true. So since this is proven, we go back to the original scope line.